In this particular question, we've been asked to evaluate the integral of 5x squared times e to the 3x dx again. Now, if you remember when we did this previously, we were required to use the integration by parts twice, and that was a pretty long and arduous process. Instead here, what we're going to do is use a shortcut. It still involves integration by parts, but it's referred to as tabular integration. We start by defining two functions, f of x and g of x, and we're going to let f of x equal 5x squared and g of x equal e to the 3x. Now we're going to set up a chart, and the first column in our chart is going to be made up of f of x and its derivatives. Well, f of x is 5x squared, its derivative would be 10x, the derivative of that would be 10, and the derivative of 10 is simply 0. We stop at that point. As soon as we get our derivative of 0, we stop. You'll notice that we have 4 terms in this column now. Now our other column is going to be g of x and its integrals. So we'll have e to the 3x. The integral of that is 1/3 e to the 3x. The integral of that is 1/9 e to the 3x. And the integral of that is 1/27 e to the 3x. We stop now because if you remember in the first column of this particular chart we had 4 terms. Well, we now have 4 terms in our second column, so that's where we stop. Now what we're going to do is I'm drawing some arrows here to show that we're going to be multiplying certain values together. We're going to be multiplying the 5x squared times the 1/3 e to the 3x. We're going to multiply the 10x by the 1/9 e to the 3x and the 10 by the 1/27 e to the 3x. Now I've also indicated some signs here, and what's that to tell you to do is to indicate whether we're going to be adding or subtracting these particular products. So now how do we put all this together? Well, I'm going to restate our question again. We've got the integral of 5x squared e to the 3x dx, and now that's going to be equal to our first product, which is the 5x squared times the 1/3 e to the 3x. Subtract from that the product of 10x and 1/9 e to the 3x. Then we add to that 10 times 1/27 e to the 3x. Now what I'm going to do is just, if you look at all of those terms, they all have a e to the 3x common to them. I'm going to common factor that out, and I get e to the 3x times, in brackets, the following quadratic expression, a 5/3 x squared minus 10/9 x plus 10/27. And then we add to that c and indicate that c is an element of real numbers. Now if you compare this answer to the answer that we calculated previously using the longer, more arduous approach, they still both involved integration by parts, you'll notice that the answers are the same. This is just a far easier way of handling the question. Intuitively it doesn't make as much sense, but you can see that you end up with the same solution.